right, everybody, get ready. Because we're going all the way back to the beginning, like way back. We're talking about the birth of the universe, the biggest origin story ever. And wow, you guys sent in some really interesting stuff. I am definitely feeling some cosmic vibes. We've got research papers, articles, and even some notes that are, well, pretty funny. We're going to cover it all from the Big Bang to the first stars in the universe. It's going to be epic. And lucky for us, I've got our universe expert here with us to help us break it all down.
I'm so ready. Let's do it.
Okay, so let's start before the Big Bang happened.
Yeah.
One of the sources describes it as nothingness chilling like a villain, which I gotta say is a pretty awesome visual. But what does that even mean? What was there before the Big Bang?
Well, that is a very tough question to answer. It's one of the hardest things to really wrap our minds around,
Yeah.
Try to imagine just a void where there isn't even any space or time. There's no matter, no energy, nothing. Not even the laws of physics, so it truly was nothing.
Wow, okay. So we've got this nothingness just hanging out, and then boom, the Big Bang. Or actually not a bang, as one of the sources points out. There was no huge sound system or fireworks or anything. So what exactly happened?
Right. The term Big Bang can be kind of misleading. It wasn't really an explosion the way we think of it.
Okay.
Think about the entire universe crammed into a point smaller than an atom. That's called a singularity. And then suddenly this teeny tiny point starts expanding really rapidly. It's stretching space itself. And that's how the universe's evolution started.
So it was more like a huge expansion than an explosion.
Exactly. It happened unbelievably fast.
Wow.
And it was from this super tiny point. It's really hard to even imagine the scale of it. Picture something like a pea inflating to the size of a galaxy in just a fraction of a second.
Hold on, I need a second to let that sink
Yeah.
in. Okay, so the universe is expanding faster than I can think. What happens next?
Well, things get pretty wild. Your source uses the analogy of a cosmic mosh pit of particles, which I think is a pretty great way to put it.
Ooh, a cosmic mosh pit. Tell me more about this. What kind of particles are we talking about?
As the universe expanded, it cooled down too. And as it cooled, all this pure energy started transforming into matter, which is based on Einstein's famous equation.
Yeah.
And that's when we start to see quarks, electrons, neutrinos, all these fundamental particles formed. And they're just zipping around super fast, crashing into each other and interacting in all this chaotic energy.
So it's kind of like a universe-sized pinball machine.
Yeah, exactly.
So everything we see around us, our phones, our pets, our bodies, it's all made from these little particles.
It's true. Every atom in our bodies came from this chaotic early universe. Like, we really are made of stardust.
Okay, now that is the coolest thing I've learned all week. Stardust. I'm going to start introducing myself that way. But how do we go from this crazy mosh pit of particles to the universe we see today? With all the stars and galaxies and planets and everything.
Well, things start to calm down at that point. We go from pure energy and particles to a time when light can finally travel freely. And this is where we see the proof of the Big Bang, the cosmic microwave background, or CMB.
Oh yeah, one of the sources called that the baby photo of the universe.
Exactly. The CMB is like a faint afterglow of the Big Bang. It's like a snapshot of what the universe looked like when it was only 380,000 years old. Before that, the universe was so hot and dense that light couldn't travel through it. It was like a fog. But as the universe kept expanding, it cooled down and became transparent, and that's when light could finally travel.
So this light, the CMB, has been traveling through the universe ever since the very beginning.
That's right. And we can actually detect it with telescopes. Can you believe that? We can look back in time to the very beginning of the universe. And you can even hear a little bit of the Big Bang on the radio.
Wait, really? You're telling me that radio static, that annoying hissing sound, is partly the sound of the Big Bang?
Yep.
A little bit of that static is the cosmic microwave background radiation. It's like an echo from the early universe.
Wow, I am never going to complain about radio static again. It's like listening to history. Okay, so we have this expanding universe full of light and particles. They're all starting to settle down a little bit. So what's next? What happens to all these particles?
Well, that's when a new force comes into play.
Mm-hmm.
It's a force that shapes everything in the universe. Gravity.
Gravity. It's always bringing things down. But I guess in this case, it's actually bringing things together, right?
We got it. Gravity starts to pull all those particles together. Most of them are hydrogen at this point. One of the sources says it's like gravity is saying, "Come here, you adorable little things," which I love.
I know, right? Science and humor are the perfect combo.
Okay.
So gravity is like a matchmaker for all these particles. But then what happens?
Well, as these clumps of hydrogen get denser and denser, the pressure and temperature at their cores get super high. And eventually, nuclear fusion starts. That's how the very first stars are born.
Wow. from nothingness to the very first starlight. It's a pretty amazing transformation. It was a huge moment in the universe's history.
So I'm picturing these first stars, and I'm thinking they must have been pretty different from our sun. What were they like?
You're right to think that. The first stars were massive, much bigger and hotter than our sun, and they burned through their fuel really quickly.
So I bet their finale was pretty epic.
Oh, absolutely. They went out with a bang. Literally. They ended their lives in supernova explosions.
Yeah, one of the sources called it a blaze of glory. I love it. So what happens during a supernova?
Supernovas are some of the most powerful events in the universe. They release a ton of energy, like way more than we can even imagine. For a short time, they're brighter than entire galaxies. But the really important part is that supernovas create the elements that make life possible.
Hold on, you're saying that we can thank exploding stars for life?
In a way, yes. The intense heat and pressure of a supernova creates heavier elements like carbon, oxygen, nitrogen, and even gold.
Wow.
All of the elements that are essential for life are made in these supernovas.
So you're saying that the gold in my earrings was once part of an exploding star?
Exactly. It's like a little piece of a star, a reminder of something that happened billions of years ago.
Wow. Okay, so we have these clouds of gas and dust ready to make new stars and planets. What happens next? How do we go from stardust to a solar system like ours?
It's gravity again. These big clouds, which can be light years across, start to collapse in on themselves because of gravity.
So it's like a cosmic implosion.
Yeah. And as it collapses, the cloud starts to spin faster and faster.
I'm picturing a giant spinning cloud of dust. What's happening in the center?
Well, in the center, the density and temperature are the highest, and that's where a new star is born. The core ignites and fusion begins, and a new sun is born.
So that's how a star is formed. But what about the planets? Where do they come from?
As the cloud keeps spinning all the leftover material, the stardust starts to clump together around the new star.
Okay.
It forms a swirling disk. Imagine tossing pizza dough and little bits stick together. It's kind of like that.
Okay, I can see it. So these little clumps of stardust, they become planets.
Over millions of years, these clumps get bigger and bigger. They pull in more material from the disk. Some of them turn into rocky planets like Earth, and some of them become big gas giants like Jupiter and Saturn.
It's amazing how one cloud of dust can make so many different planets.
Yeah.
See, our solar system, it's like second generation.
Right.
It came from the leftovers of those first stars that went supernova.
Exactly. Our sun, our Earth, everything in our solar system is made from recycled stardust.
It really makes you feel connected to everything, doesn't it?
Definitely. I want to know what your sources say about the fate of the universe. What's next? What's the next chapter in this cosmic story?
It's a big question. The fate of the universe is something I think about a lot, and our sources actually have some really cool ideas about it.
Awesome. Well, let's dive in and talk about them.
Okay, so we've gone from the Big Bang to stars and planets, all thanks to those amazing supernovas. But what happens next? What's the future of the universe?
That's the big question, right? It's something that people have wondered about for a long time, and your sources have some really interesting ideas about it.
Oh yeah, I'm ready. Tell me everything.
Okay, get ready for some crazy possibilities. One idea is that the universe will keep expanding forever, like a balloon that never pops.
Forever. Wow. What would that mean for everything? For the stars and galaxies and planets like Earth?
Well, for a really long time, I'm talking billions and billions of years, galaxies would move farther and farther apart. They'd be like ships passing in the night. Eventually, new stars would stop forming because all the material would get used up. The universe would get colder, darker, and emptier.
That sounds kind of sad, like the universe is just winding down. Are there any other possibilities? Anything a little more cheerful?
There is. Another idea is called the Big Crunch. It's like the Big Bang in reverse.
Ooh, a cosmic rewind. Tell me more.
So in this scenario, the expansion of the universe slows down and then it starts going in the opposite direction. Gravity pulls everything back together, galaxies start rushing towards each other, and eventually the entire universe collapses back into a single point. Just like how it started.
So it's like a giant reset button for the universe. Does that mean time would start over? Could there be another Big Bang?
Those are good questions. Some cosmologists believe in a cyclical universe where it expands and contracts over and over again for eternity.
Wow, that's pretty wild. So we have eternal expansion and a cosmic collapse. Are there any other possibilities?
There's one more, and it's the most dramatic one, the Big Rip.
The Big Rip. That sounds intense.
Okay, so imagine the universe is expanding, but it keeps getting faster and faster. It's like someone's hitting the gas pedal on the universe. Eventually, the expansion gets so strong that it overpowers everything else. gravity, electromagnetism, even the forces that hold atoms together.
Whoa! So everything would just get ripped apart.
Yeah.
Galaxies, stars, planets, even atoms.
Exactly. It's like the universe just unravels. It's a pretty extreme idea, but some scientists think it could really happen based on what we know about dark energy.
Okay, I need a minute to wrap my head around all of this. Eternal expansion, a big crunch, or a big rip? Those are some pretty intense possibilities.
I know, right? The truth is, we don't know for sure what's going to happen. But that's what makes cosmology so exciting. We're always learning and discovering new things about the universe. Who knows what we'll figure out next?
This has been an amazing deep dive. We've covered so much, from nothingness to stars and planets and the fate of the universe. It's mind-blowing. But you know what really stands out to me? It's the fact that we're here on this little planet, and we can look up at the stars and think about all of this.
I know, it's amazing, isn't it? We can not only observe the universe, but we can understand it, we can figure out its history and think about its future.
We started with nothingness, but it turns out there's so much out there. There's always something new to discover. And the coolest thing is that we're a part of it all. We are stardust.
That's a great way to put it. We're all part of this amazing cosmic story.
Thank you so much for joining us on this deep dive. We hope you learned something new about the universe. Keep looking up at the stars and asking questions. Until next time, keep exploring.